So we're writing sine cosine equations given a graph. Yesterday, the last lesson, what we did was they gave us the amplitude, the period, other information. We wrote the equation. Now we're going to take that information from the graph and do the same thing. So it says write the equation for the graph given below. So the first thing we've got to figure out is any important information that we need. The first thing that you need to figure out is it a sine or cosine graph?
Sine.
Okay, why do you think it's sine?
Because it's in the center.
Because it goes through 0, 0. So we know it's sine, so I can kind of write this y equals, and I can put the sign there. So we know it's sine because it's going through the origin there. All right, so it's starting with the up instead of being at the top. Okay, and so let's look at some other information. I need to figure out what number goes here. Is it reflected? No. So there's no negative. What's the amplitude?
3.
3. So I'm just going to put a 3 here. All right. The other thing we need to figure out is the period. So the period, t, we're going to take 2 pi. So the period, I guess, if we're looking at it, is pi, because it starts here, starts over at pi. Mark and mark.
I don't know what I'm laughing at.
Okay, so when we're putting the number in here with x, I've got to do something with that period. So it starts over every pi. So then b is the number that goes in here, and that's 2 pi divided by the period. So I put pi in there.
Just 2?
So it's just going to be 2. And then I want to look and just make sure, okay, we didn't translate it up or down or anything weird, so I don't need to add anything onto the end. And that'll be it. So mostly what we're going to look at today is you're going to have to figure out amplitude, period, if it's reflected, and then we'll add in those translations later so that we can get kind of a grasp on what's happening. Yes?
What is it? Can your lines like squeeze in and go downwards, like down the y-axis?
Yeah, we'll talk about that in a little bit. Now, for this question, what I want to do is show you how you could check your answers. There's no reason if you have a graphing calculator to miss any of these. So if you go to your calculator, the y equals menu, I could type in 3 sine of 2x like that, and I could, although I need to do zoom trig, which is number 7, and that will take me to a negative 2 pi to 2 pi window, and it'll give you kind of what this looks like. You have to have some basic knowledge. This is going all the way out. I think 2 pi is in here somewhere, so the top of this one would be where this is. Your calculators will probably look more like what's actually on the paper because you don't have these, the newer ones. But you can kind of get an idea. Okay, it's going up to 3, and you can see about what it should look like.
I did mine. Okay? Look at it.
Okay, so that's a way you can check. It's not perfect because the screen may not be exactly like this. If you're using the calculator, it has to be in radian mode, and you have to do a zoom z trig, at least for the first one that you do, to set the window, because it sets it from negative 2 pi to 2 pi, which is what most of these are set up to do. Okay, just an option. Let's look at number 2. So is number 2 a sine or cosine?
Cosine.
Cosine. I know that because it's not starting at 0, 0. It's starting with that maximum point that goes through the y-axis. So I know that it's going to be a cosine graph. And then what is the amplitude? 4. Now, some people last year were like, it's 2. There's 2 boxes, but you have to look at the scale. There's 2, 4. And it's not reflected, so I can go ahead and just put a 4. We'll talk about reflections in a little bit. What's the period for this? So it starts here. Where does it start over? So it starts here, it goes down, it comes up. It's starting over at pi over 2. So my period is pi over 2. So to figure out what number is going to go here, I would have to do that trick we learned yesterday, 2 pi over 1, and then I flip this over, and I get 2 over pi, and you end up with 4. Some of these you're going to do so often, like the pi over 2. You may just remember because you did it 3 or 4 times yesterday, it just comes out 4. That's fine. And then if you want to, you can check that on the calculator, but I know because I'm looking that is correct.
So fast and violent. Look at it.
Okay. All right, so now we're going to start talking about reflections a little bit. Okay? So let's look at number 3. So when I'm looking for sine or cosine, it does not go through 0, 0. So it's going to be easier to do cosine. You could actually do sine or cosine on these if you added in a translation left and right. We're just going with what's the easiest, simplest, shortest equation. So it is reflected though, because normally it starts up here. They've reflected it over. So since we're starting with sort of that minimum value, I know that that's going to be a minus. The amplitude is 2, so I'm going to make it minus 2 cosine. And then we've got to figure out the period. So if you start at the y-axis, it's down here at negative 2. I got to see it's going all the way over to 2 pi before that starts over. So the period is 2 pi. So that means this number in here is going to be 2 pi over 2 pi, which it all cancels and gives you 1. So you can either write 1x, or if we want to keep it really simple, we could just put an x. We wouldn't need the parentheses. You can put the 1 with the x if you want to, but that's optional because it's 1. 1x and x are equivalent. And there's no weird slides or anything going on, so that's it. Okay? Let's look at number 4. It goes through 0, 0, so is that sine or cosine? Sine. And then my amplitude looks like it is between 4 and 6, so we'll say 5. With a normal sine wave, it would go up like this. Since it's going down instead, that means it's flipped. So negative 5. So if it goes through 0, 0 and it goes down over here instead of up, that means it's been flipped. Now the period's a little interesting because I start here and go up, I'm only getting half the wave. So I could go over here and go, okay, this is where it starts. It goes up and down. That distance is 2 pi. And then this half of it is over here. That distance is 2 pi. So 2 pi and 2 pi make 4 pi. So the period is 4 pi. The number that's going to go in here with the x is going to be 2 pi divided by 4 pi, which reduces to 1/2. So you can write 1/2 x, or we talked about before, you can do negative 5 sine x over 2. Anytime you see that fraction like that, you can break it apart and put the fraction in front, or you can leave it together. It means the same thing. Okay? Let's go down to number 5. Okay? Sine, so it's a sine, so we have y equals sine. What number is going to go out here? So we're going to have a 5. Is it positive 5 or negative 5? What?
It's the same thing.
Isn't that the same?
Is it the same exact one?
Yeah.
Okay, put an X on that one. Sorry. Oh, and you know what? I glued something over the top of that last year. We're going to do that again. It's okay. It's not a problem. It's just some information. I think I figured that out last year, and I was like, well, instead of leaving that X, we'll put something on top. So let's look at number 6. Sine or cosine? Cosine. Is it reflected or is it okay?
Okay.
It's reflected. Not that reflecting isn't okay, but so what number is going to go in front of cosine? 2, because the amplitude is 2. And then the period's a little interesting. I have this like number here. It's like halfway done at 2 pi, so you can kind of imagine it would go out, and at like 4 pi it would start over. Or you could use these bottom points to see kind of a starting point, ending point. So it would be 4 pi, you're right. This is 2 pi to there. That's 2 pi to there. You could also think about the starting point where it would start over. It's halfway done with its wave at 2 pi, which means it would be all the way done at 4 pi. So the period is 4 pi. And so the number would be the same as the one that we did up here on number 4. We can just use a half. So you can either write it 1/2 x, or you can write it 2 cosine x over 2. So that's as far as we're going to go with it today. But you have to find the amplitude, period, figure out if it's reflected. Then if it happens to be slid up or slid down and the midline moves, it gets a little bit more exciting, but we will tackle that later.
So